All right, so we flip in the classroom this semester. We're going to give it a shot. Take good notes. Okay, you're going to get credit for your notes. It's the first thing I'm going to check when you come in. Check and make sure you took notes. All right, so we have the key features of what we call exponential functions. So as we grab through here, let's look at this vocab. Some of this stuff we'll talk about another day. Exponential growth function is something that grows exponentially. All right. Decay would be vice versa. It would start high and kind of flatline. And these things never actually hit a value of 0 because they are decaying or they are growing. You can't grow from 0. You have to be a little bit more because 0 times anything would be 0. The big one here is what we call horizontal asymptote. You'll notice my two little rough graphs I drew here, they have an imaginary line that they're not crossing, and that's called a horizontal asymptote. So it's a line that can't be crossed away from the origin. It's also called end behavior to some degree or long behavior because it is a reference to long-term behavior. Here is the mother function. F of x is a times b to the x, and we're just going to insert a 0 and a 1 into that equation and see what we get. It's for x, so this will look kind of funny. We have a times a b to the 0, and I know that anything to the 0th power is 1, so this is just a. So all exponential functions contain the point 0, a. Weird, huh? There's a point called 0a. If I throw a 1 at this thing, I would have a times b to the first, which is just ab. So 1, and then we have some point ab. Kind of weird how that is, just no numbers really. Ugh, what is that? You have a new mom function, which means your next graphing quiz is going to have this guy on here. And that's what it looks like. Now, its domain is it's running left forever. That could take you to negative infinity. And even though it's climbing, it's also running right forever. That will take you to positive infinity. Its range, we have this value that's really close to 0, but it never actually hits 0. So that is a parenthesis, not a bracket. And then it rises to infinity. And I guarantee you a couple of them will be like, well, why can't it hit 0, Milbrath? Because it can't. It just cannot do it. You have to have a starting place. And if you start at 0 and exponential functions grow through multiplication, you have to be more than 0. All right, now there's this imaginary line that exponential functions, at least the mom, cannot cross, and it's y equals 0, and it is the horizontal asymptote. It is the horizontal asymptote. All right, there's your mom function. Time to do some graphing. Where the key features of each function include the domain, the range, the intercepts, the asymptotes, and the end behavior. So, we have this rule about what we contain. All points contain, and I'll show it through a table, but we must contain 0a, and then we must contain 1 comma ab. So this is in the form of that mom function. A is 8, and b is a half. 8 times a half is 4. So it's going to contain 0, 8, and 1, 4. If you made a table, you'd see it too. If you plug in a 0, you'd have a half to the 0, which is 1 times 8. If you plug in a 1, you'd have a half to the first. 8 times a half is a 4. If you plugged in a 2, you'd have 8 times a half that is squared. If you square a half, you get a quarter, and you get a 2. This is legit a halving function. As you move left to right, it is taking half of this thing repetitively. This is actually what we call decay. There's a rule about decay. It is decay because you are decaying or decreasing from left to right. So this thing's going to start high, and it's going to come in and it's going to flatline on the x-axis. A flat line on the x-axis happens to be its horizontal asymptote. All right, there's lots of things they asked for. The domain is negative infinity to infinity. The range is 0 to infinity. Parentheses, by the way. By the way, if you like set builder, you can still use set builder. All values of x such that x is an element of the real. The range would be all values of y such that y is greater than 0. And let's see, what else are they talking about here? They want the intercepts. There is one intercept right there. There is when I talk about my intercepts, there is a y-intercept. It was at 0, 8. Notice that x was 0. That's how I came up with it. Some of you have not connected dots yet. I understand, y'all. There is no x-intercept. Can't ever be an x-intercept on this one. Asymptotes. We have a horizontal asymptote. It is at y equals 0. End behavior. You guys are familiar with the layout on end behavior. But as x runs left, which means I'm running towards negative infinity, the y value is increasing. Okay, also, as x runs right to infinity, the y value is approaching 0. All right, 2 down, 3 slides to go. Transformations. Now don't be surprised by the form here. The form here is y equals a times b to the x minus h plus k. Normally b is something to deal with the horizontal here, but it's just taking that a times b to the x and playing with it. That's all it is. A here is actually 1. It really is. Now, this will be a little bit different because we have shifts going on. So we can't just do like we did by plugging in a 0 and 1, because there have been shifts going on. So we have to pay attention to that. Be comfortable with the forms that you've already studied. This is a right 2. This is an up 4. This is, however, not initial slope. It is and it isn't. Like it's kind of weird. It's slope from the origin, I can say that much. But it's not slope from the first point you plot. So it's a little bit different. Anyways, we're going to go right 2 and up 4. And I highly suggest that you draw in these shifts. I wish I would have done more of that all year long. It's just y'all were resistant to it, so I didn't feel like messing with it, fighting that battle. But it pays dividends on exponentials and logarithms to draw in these shifts. So I'm going to start drawing them in like I should have been doing the whole time. I am going to graph this thing. This is 3 to the x. If I feed it a 0, I'd get a 1. If I feed it a 1, I'd get a 3, because 3 to the first is 3. So 0, 1, and then 1, 3. Now, notice I talked about this kind of not being slope anymore. It is if you think about with respect to the origin. Pay attention to that. I rise 3, run 1 from the origin, not the first point I plotted. So there's that. All right. Now, what we're going to do is we're going to take these 2 points and we're going to go right 2 and up 4. So I'm going to go right 2 and up 4. It's going to put me right there. I'm going to go right 2 and up 4. It's going to put me right there. And I'm going to redraw that original function right there. So what's the domain of this guy? It's negative infinity to infinity. All exponential functions have domain of negative infinity to infinity. It's the range that can change. So on this exponential function, the lowest y value happens to be ridiculously close to the horizontal asymptote. It's 4, and then it rises to infinity. The end behavior, as x runs left to negative infinity, y is approaching 0 because see it's fallen. And as x approaches infinity, it is increasing. Four out of 5 done. There's one more that I'm going to do with you in these notes, and it's this guy. Let's talk about our shifts here. This is a down 1. This is a right 3. And that little negative symbol, that is a vertical reflection. So I'm going to start by graphing 2 to the x. You'll notice I just make tables, 0, 1. Plug in a 0, you get 1. Plug in a 1, you get 2. Tables are really where it's at on exponential functions. You cannot screw up if you make a table. All right, so let's see here, 0, 1, 1, 2. And that's something that has kind of been lost over the years, is computational sense. Back in 2012, kids struggled a little bit with factoring, but not much. Around 2015-16, you notice that kids really struggled with multiplication. So suddenly factoring became really hard. And now it's 2024 and kids can't add. So all of this stuff is hard. I don't know what happened. But anyways, this is 2 to the x. Now I'm going to draw in my shifts. I am going right 3. And I'm going down 1. Now pay attention as how this was 2 and that guy. It's going to be a little bit different. It's going to be down 2, okay? I'm going to make a table. And I just really feel that tables are where it's at. But a table at least explains why things work the way they do. Notice I went right 3. This is going to be my first x value. I went right 3. I'm going to put a 3 in here. And then I'm just going to go 1 over, okay? So this is your initial shift. And then I just add 1. That's where those numbers are coming from. And then you have the computational skills, you know. Let's see what f of 3 is. So it's negative 2, 3 minus 3, minus 1. 3 minus 3 is 0. And anything to the 0 is what? It's 1. Even if it's a negative. Now this happens to actually be, forgive me, this happens to be a negative 1, minus 1. So it's actually negative 2. That will get some kids. I know it's not the negative 2 that's to the 0, it's the 2 that's to the 0. So I get to put a point at 3, negative 2. If I plug in a 4, see what happens. That'll give me a negative 2 to the first, take away 1. And a negative 2 to the first, or sorry, a negative times a 2 to the first is simply going to be negative 2. And negative 2 minus 1 is negative 3. So 4, negative 3. Now again, notice that negative 2. I fell 2 and I ran 1 from the origin, from the centering. That's how it's done. Let's see here. Now, what's it going to look like? It is a vertical reflection of this thing right here. So this thing is flipped over the x-axis. And it looks like that. That's how she looks. And there you go, kids. Now let's talk about all the stuff we're supposed to talk about. The domain of my black function here, this is your f of x function, is like any exponential, negative infinity to infinity. Her range, the low y value is negative infinity, and she rises to a negative 1. Okay, let's see here. What else do we want here? We want the long range behavior. So as x approaches negative infinity, the y value is approaching 1. And as x approaches positive infinity, the y value is falling to negative infinity. And the last thing we want is this horizontal asymptote. Notice I'm writing these in the forms of y equals. I'm not just saying it's 1 or 2 or 3. It's legit y equals negative 1. And when you're talking about shifts, pay attention to that guy, because that is the horizontal asymptote. There you go. Now, there's 2 for you to try, and I'm going to make them up real quick, but these are going to be the first things we do in class when I see you on, I think, the Tuesday, maybe the 8th or something like that. But these are the ones that you need to be trying. So you try. Let's see, let's graph 4 to the x minus 2 plus 3. And again, you're going to state the domain, range, and horizontal asymptote. Let's make up another one. You try. F of x equals negative 3 times, or not times, raised to the x plus 3 minus 4. And again, you're going to state the domain. You're going to state the range. And I want you to do the end behavior. And I also want you to do the horizontal asymptote. There you go, kids. Day 1 of flipping.